Hello, hi students. So in this video, I will show you one example related to uniform flow channel and how can we calculate the Q according to Darcy-Weisbach equation and Manning equation. So let's read the question together. A uniform flow channel has 3.6 cubic meter per second water discharge. Okay, as we go, let's write down the information given. So in this case, Q is given as 3.6 cubic meter per second. Okay. Okay, the channel is a long rectangular channel. So it says here that it is a rectangular channel with a 3 meter wide. So it's given here the width of the channel, which is B equals to 3 meter. Okay. And of bed slope equals to 0.01. So bed slope is S naught, so it is given as 0.001. So in uniform flow, we know that SO is also equals to friction slope. Okay. With a depth of flow of 0.8 meter. So the depth is 0.8 meter. So this is the depth. Okay. So Y is equals to 0.8 meter. Okay. And water temperature of 15 degrees Celsius. 15 degrees Celsius. Okay, so estimate the discharge of water at 15 degrees Celsius when the depth is 1.5 meter using A. Manning equation and B. the Darcy-Weisbach equation, and state any assumptions made. Okay, so in this case, this information is given from the question. So in this case, y is equals to 0.8. But the question wants us to find q when y is equals to 1.5 meter. Okay, so let's look at Manning equation. Okay, so Manning equation is this part. Okay, this is v, and to find q, then it's equals to av. So in Manning equation, so in this question, SF is known. We know SF, and we can find R. Of course, then we can find A, but what we do not know is N. N is related to the roughness or to the friction. When the material of the channel, N is related to the material of the channel. So since in this equation we do not know anything about N, so we have to find N in this case, yeah? Okay, so as usual, we can start with the easiest one. Okay, so the easiest one will always be something about the area and this R. So A is simply Y times B. So we have 0.8 multiplied with 3. So this is equals to 2.4 square meter. And then we can find the wetted parameter. So wetted parameter is y plus b. So 2y plus b, which is equals to 4.6. So 4.6 meter. And then we can find r, a over p. This is equals to 0.52. Okay. So of course, you know that this part of the equation is V, right? Okay, so V is equals to R to the power of 2 over 3 divided by N multiplied by friction slope to the power of half. Okay, so we can find we can find N already. So N is equals to Okay, from this equation, we have already all the information here. Or not yet, because we have to find V, right? So this equation times SF have to divide by V. So V, since we know that, okay, since we know A, so we can always find B. Okay, you have Q given A multiplied by V. So in this case, Q 0.6 over A, which is 2.4, is equals to what is V? 1.5 meter per second. So we use this value to find N in this case. So then N is equals to, you put all the values here, and then you will find N as 0.0139. Okay, so now you know all the parameters here, all the values here you already know. Then you can you can find Q at depth is equals to 1.5. Okay, so let me show you the simple step here. Okay, and the question is to find Q when Y is equals to 1.5 meter. So in this case, you have A, you can calculate A, you can calculate R, and you know your N value, which is from this answer, and you know your SF, right? And then you can find Q according to Manning's equation is equals to 8.54 meter square. Okay, this is very simple. Try this exercise. Okay, I will continue with Darcy-Weisbach equation in the next video. Okay, bye.